I got drawn in on sort of into the subject about what happens after the fire, and I just want to share some experience with you.
I learn so much by talking to other people that I meet, and I make really long-standing connections.
Pouring water onto an EV in thermal runaway is like pouring water onto the roof of your house when your kitchen's on fire. Thank you, gentlemen.
Good morning. My name is Doncaster. It's great to be here again and great to share and learn with everybody else at the conference. I'm Managing Director of Fire and Smoke Solutions. We are expert designers and installers of all types of smoke ventilation system. I started my career in the nuclear industry, and then for about the last 35 years I've been working in facilities, specialist facilities design, fire and smoke ventilation, and for the last 15 years or so I've represented the IMechE on FSH 25. I'm a UK expert for European standards, and I also develop best practice with the Smoke Control Association. So I'm representing the Smoke Control Association today. The Smoke Control Association is a trade body that represents the smoke control industry, and it requires its members to be third-party accredited and to meet best practice standards. So, we're going to talk a bit about smoke shaft construction today. What's a smoke shaft, what it does, what it's made of, the standards that apply, some typical tests, and some solutions. So, what we've got here is a typical, what one would call a smoke shaft. So a smoke shaft is for transmitting smoke from inside a building to outside a building to protect spaces. So in any building we have to protect the staircases and the escape routes. So they can be used for smoke extract systems, and they can be used for air relief and pressurization systems. But I think it's important just to pick up on the shaft. So the term shaft is used very generically within the construction industry, and it's used to describe a vertical construction through a building. So you have all types of shafts. You have riser shafts, service shafts, fire shafts, but they're all generically a construction through a building. And we also have the term duct used, and ducts often used to describe prefabricated sections that are put together, and sometimes for horizontal sections. But however we use these words, when we're talking about smoke shafts, we're talking about a function. And so as far as this presentation is concerned, we need to be focusing on the function rather than the name. So inlet paths and reversible systems are likely to fall under the same sorts of requirements. But just to come back to the use of language, the standards can be very ambiguous about what is a shaft and what is a duct. And I think that has led to some level of misunderstanding within the industry. So, what are the functional requirements? Well, in the UK, everything really depends on building compartmentation. Everything we do relies on that. So that has got to be king in everything we do. And for a smoke shaft, it needs to maintain building compartmentation. So we have EIS, integrity, insulation, and smoke rating. And those are the important things that it will need to cover. We have reaction to fire. It doesn't want to burn. We need it to maintain a clear path for the smoke to get out of the building. So it's got to maintain its shape and its size and its clear area. It needs to be able to resist pressure. Now, it's quite clear when you have a powered smoke shaft or a powered air relief shaft that it has a pressure applied to it to make it work. So we need to make sure that the construction is capable of resisting that pressure. But there's a common misconception that natural smoke shafts don't have much pressure. Now, we were looking at this and we decided that we'd do a bit of modelling. And from our own CFD modelling, we got some results that maybe in a natural shaft you could get possibly 200 pascals as a pressure, which a lot of people are saying, well, that can't be. But if you take the worst case fire, you take a small lobby, a tall building, you can get some quite extreme results. The smoke shaft needs to be durable for the life of the building. Clearly, it's an important function. It needs to be appropriate for however the building is designed and for how long it's going to last. And the final function really is that it's going to have some smoke dampers in it, smoke control dampers in it. Now, I think we've managed to move people on and explain the difference between fire dampers, fire smoke dampers and smoke control dampers. So I don't think there's a lot of misunderstanding about what a smoke control damper is now and what it does. But dampers should be tested to EN 1201 Part 8, and they will have manufacturer's certificates and DOPs, and there'll be methods of installing them into construction. So the system needs to be capable of coping with that. So traditionally, what we've done in the UK, well, the historic practice has been on what's available, what materials are tested, the standards of the time. So this is constantly changing, and the building practices have changed, the industry's moved on, and that's the nature of life. So traditionally, block work or poured concrete was probably used, and then plasterboard, gypsum, shaft wall type construction started becoming more popular. And then we have a mixture of materials where we've got a bit of everything all put together. And all of that's commonly referred to as builder's work construction. And normally you would see a builder would do that stuff, a smoke ventilation specialist would do the sucking bit and the damper bit, and that's how a system would get put together. We've also had metal duct gets used, and that might be insulated or uninsulated, again, depending on the application. So if we look at the specifications that have been applied, reaction to fire, people want to make it out of something that's non-combustible. Now, in the recent version of ADB, like I say, things are always moving on. The materials have been specified as being Class A1. If you go back historically, we've seen shafts with wood in them. We used to have shafts with plasterboard, with paper on them, all of things that would now not be acceptable. But that's again how things move on. And the other standard that's always been applied is leakage, 3.8 metres cubed per hour per metre squared at 50 pascals. And that really started back in the 90s when shafts were made out of block work, and we needed some sort of standard. So the only published standard was for leakage of block work. So that became the standard, and ever since then it's been replicated over the years. Compartmentation has always been based around BS 476 tests, and nowadays it's now moving on to European standards. One of the things that is noted in EN 121 on Part 6 of the 2013 version was that block work should be lined. So it was being recognised then that there was some issues with leakage. And gypsum board systems, recently it's been recognised that they're not suitable for smoke extract. And they will be tested to a fire test that was for fire rating rather than for smoke shafts. We've also used metal ductwork, and traditionally that would have been BS 476 ductwork through those standards. More recently, people would tend to apply for multi-compartment 1366 Part 8, and for single compartment 1366 Part 9, and then classification to 13501 Part 4. And CE marking has always been there as a requirement since the CPR. However, the standard that would apply for smoke duct sections, Part 7 of EN 12101, has always had a little bit of a history in terms of nobody agreeing how to apply it. So we have a situation where some test houses will agree one thing, another test house will agree another thing, and so it's a problematic area. But the backstop is Building Regulation 7, which says that basically materials and workmanship must be appropriate for what you're doing. And there's a hierarchy of selection in there, and it will start with CE marking, and it will go down standards, guidance, and at the bottom is, well, we've done it and it works. So there is a hierarchy that we can go through to decide if things are right. But again, I think it comes back to this thing is, when is a duct not a shaft, and when is a shaft not a duct, and is it the function that determines what's required or the test requirement? So for smoke-controlled ducts, the standards are quite clear. The EN 12101 suite of standards apply for all smoke ventilation. So we've got standards for fans, for products. We've got standards for smoke control dampers. We've got standards for power supplies. And we do have Part 7 in there for duct sections. But again, the question about whether something that is manufactured in a factory and assembled on site, or something that is manufactured on site, it can be covered, is the question. But the testing classification standards are really very clear. And again, for multi-compartment, 1366 Part 8, single compartment ducts, 1366 Part 9, and then the classification to 1351 Part 4. So, what I got here is a typical furnace test. And in this particular example, we can see that there is, point will work. We have a smoke control damper that has been fitted into a shaft within inside a furnace, and another smoke control damper outside the furnace, again in this shaft here. And this particular shaft is made of a glass-filled gypsum product, and this would have been a typical sort of fire test that has been done. We have some similar sorts of tests, and this is a test that has been done on a blockwork shaft. So you see the blockwork shaft inside the furnace, blockwork shaft outside the furnace, and you can see there's a damper fitted on the side here. And this was a test on cellular concrete. When we look at this, it's quite clear that there's been a failure of the duct, and the blockwork has cracked. Now, it might pass a fire test, but it certainly won't pass a smoke sealing test. And so the smoke sealing ability of that has been breached. We also have issues with flexi walls. Now, this particular test here was being done on some penetration seals, but I've just got it as an example to show what happens with flexi walls. So we've got a flexi wall here, and it's hot on the other side. The furnace is the other side of this bit here, and you can see the heat being transmitted through this gap here. And what's happened is it's expanded on one side, it's bowed, and this is a bit of a close-up. You can see it's come away from the brickwork it was up against, or blockwork. And again, the question about whether it passed a fire test, it might not transmit fire, but it would certainly transmit smoke. So the question of how we use flexi walls is obviously very relevant, and it's a known issue. I've got another example here where we've got a series of events, and this is concrete inside a furnace. I did have it as a video, but it's always risky playing a video in a conference because you never quite know whether it's going to go. So these are just some shots going through it, and you can see that progressively the concrete has started to degrade. Now, concrete spalling is a very well-known phenomena. It can start from about 300 degrees C, depending on your concrete. Now, I'm not an expert on concrete, and concrete is a whole science in its own right. But it's a very well-known issue. Basically, what happens is that moisture gets drawn back into the concrete, it builds up pressure, and then pieces of the concrete get ejected at high velocity. So it's like shrapnel breaking off it. And the issue can be that if you have an interface with something else, then that interface can get compromised, and again, the smoke ceiling can be breached. So recently, there have been some industry statements. The finishers and interiors sector put out a statement probably March this year. It was shortly followed by the Smoke Control Association, and then the Gypsum Products Association have also put out statements. And it's like any industry statement, they're quite measured. CIBSE are also about to put out a statement about the use of the construction of smoke shafts. So again, that's one to watch out for that will come out soon. But basically, what's come out is that people are saying that shaft wall construction is not suitable for use as a smoke shaft. And basically that's because it's tested for fire resistance, but it's not tested for the other functional requirements, such as pressure and smoke sealing. So we've entered a bit of a period of time where there's a lot of uncertainty in the construction industry about, well, what do we do and how do we deal with all of this? We've also got a question of service ducts. Now, service ducts are not smoke shafts because they don't have a smoke rating. They tend to be asymmetric. They may be three-sided, not four-sided. And so unless you have a four-sided construction, you just can't get a smoke seal, which I think was demonstrated by the tests that we've seen. 1366 Part 15 has also come out recently. Now that's a PREN. It's a draft that's out there, and that talks about service ducts and the number of size you've got and how it can work, but it excludes concrete spalling. So there's a lot of things out there. There's knowledge out there. We know about it as an industry. Again, it comes back to what Peter was saying, you know, is this relevant and how do we use it, and how do we use it to make buildings safer? So, coming on a little bit to solutions. So, smoke ducts must be designed into the system based on the application. Now, quite clearly, if you've got a 3-storey building, there's a different risk to a 60-storey building. So, we do need to be proportional in how we look at our solutions. But somebody has to design it, and I think as has been said previously by previous speakers, the question about who takes responsibility for things and how does it all come together is the important bit. And so when you're designing a smoke control system, it will have a smoke control shaft or duct in it. And you lose that duct, you lose the system. It's fairly straightforward. So it's an intimately important part. And it will have spatial requirements. It's got to fit in the building. It's going to have technical requirements about the levels of compartmentation that it needs to meet, about the pressures, and that will depend on the size of it. So a lot of these things are interactive. It may need to be insulated, it may not need to be insulated, which would depend on how it's finished. Is it going to have boards around it? Is it going to have fire-rated boards around it? Is it going to form the fire compartment? So it's quite a technical requirement to bring that all together. And it's got to be buildable, so the sequence of events has got to be possible so you can actually make it and install it in a building. And it's got to be durable to last for the life of the building, as you mentioned earlier. And you can never get away from cost. Now, the elephant in the room is always cost. And I think we've moved on as an industry, post-Grenfell. But cost is always there. And as soon as the QSs get involved, they're basing things on cost. They're not basing things on other things. So we always have to make sure that things are cost effective and find good ways of doing things. But we can never ignore that is an issue. And the way that we structure our building contracts, the whole series of debates about that, and I'm sure they may come up during the rest of the conference. But the way the construction industry works, sometimes, as previous speakers again have said, is it dictates how things will actually get done. So, we can follow a linear approach based on standards. Now, if we follow that, we have tested products available, and we have tested products available that are traditional metal type systems, metal ducts, which may be insulated or uninsulated, and they can be formed into systems in risers and installed in various ways. And then we have construction using other materials, for example, glass-filled gypsum boards, which are commonly used in Europe but have rarely been used in the UK previously, although products have been available. So let's look at a few examples. We've got a metal duct here that's been painted. We've got a metal duct, so that would be an uninsulated type of system. We have metal ducts here that are heavy gauge with extra flanges and will pass the tests for multi-compartment and uninsulated. We have a system here that is coated, where the steel ductwork has a coating a sticky coating put on it. We have a system here where we've got some mineral fibre insulation, and we've got a system here. I'm obviously trying not to use any trade names for everything, but I think everyone will probably look at that and say, yes, it's Durasteel. So there are those types of traditional systems that have been available. And then we have board type products that have generally not been used in the UK, but are available. What we've got here is this is a job where there's some ducts just going through a floor. They've been fire stopped to the floors. They form their own fire compartment. This is a duct that's been installed in a riser. This is a job in Ireland. This is a natural smoke shaft from a basement that's been formed and would go through a natural vent at the top here. This is a mechanical system where there's a duct with a smoke control damper installed, and then it's been finished on the outside with a bit of gyp liner, so simple finish. This is just some ducts in a new build. And this one here is quite interesting. This is a shaft that has been formed by repurposing a riser in an existing building to form a smoke shaft. And this would be a tested construction certified to 1366 Part 8 and classified to 1351 Part 4. So again, a fully certified construction. And the thing about board products is you can put them into corners. You can build them from the inside out and the outside in. So there are alternatives that we may not have with metal, where we have to reach all the way around to do up bolts and to actually install it. And we can take an approach based more on Building Regulation 7 and the natural state of affairs. So we've got some examples here. We've got a shaft that's been built out of block work. We've got some concrete shafts. The one, this one here was something. This one here is something that a colleague sent me. It's made of multiple types of board. I'm not quite sure about the free area for the extract, but it's the type of thing that people see out there. So these things exist. We've got a typical sort of shaft wall construction up here, and the others are sort of block and concrete. So just to try and summarise things, the smoke shaft is an integral part of a smoke control system. If you have no smoke shaft, you have no system. So it is fundamentally important that it can do its function. And the smoke control system must be designed as part of a system that is integrated into the building. And I think we've seen this thing about when you get interfaces in a building, that's where you always get issues. And who takes responsibility for those things? And who's going to do that? And is a principal designer going to do that? And does the principal designer know who's competent to do the various bits? So all those sorts of questions are floating around the industry. And Tier 1 principal designers tell me, well, our job's quite easy, because we've just got to make sure that they're done. But then you still need someone who's competent to do those various things. So smoke shafts and ducts need to meet all the requirements for a specific application. So it's very hard to broad brush things because the requirements will be different in different types of building, and the solutions will be different in different types of building. But that comes down to things being designed. And I think it's very easy to say that there are companies that install smoke ventilation systems that are not necessarily designers, but they're expert installers. There are consultants that design things, but they never made anything. And so the question of who is competent and who is a specialist designer is key to this, really. And if you don't employ a specialist designer at an early stage, then you're liable to end up with an issue later down the line. And I think as we just touched on things here, there are so many things that are important in how you make that whole system work that you know, it's not a simple problem. You need people that have experience and knowledge and can understand how to achieve the requirements. And generic designs and cut and paste designs, we've seen them out there for years, and they probably work in most situations, but who's taken the responsibility for bringing it all together? I think it's fair to say that designs based on standards and test evidence reduces risk, and certainly nowadays everybody is trying to get a justification for everything. Anything to do with fire, people want a piece of paper. They want some justification. They want to understand how it all fits together. So more than ever, that is becoming important. So if you deviate from the standards, then whilst that's perfectly acceptable in terms of building regulations, you may make yourself a problem going forward. And so, yeah, the last sort of comment, competence. We're all talking about competence, and competence is based on training, skills, experience, and behaviour. And the behaviour thing has become more important, I think, because previously people ignored that. And the way we react to things, the way we pull that knowledge that we know about, the way that we tell people things that maybe they don't want to hear is important, because sometimes that can have a catastrophic effect on whether a system is fit for purpose or not. So, a final sort of comment, choose your designer carefully. This was a slide from when I presented before. Ross tells me there isn't a message board, so well, obviously the technology has moved on to something a little bit more extravagant than it was before. But certainly, if you want to post any questions, then feel free. And thank you.